Okay guys, question 2. So the curve C has the given equation, which is y equals 8 minus 2 to the power of x minus 1. And we're taking values between 0 and 4 for x. Now according to part A, we just need to complete a table and by plugging in the value of x equals 1. And well, that's obviously easy. Plugging in the value x equals 1 in calculator, it should look a bit like this. So 8 minus 2 to the power of 1 minus 1. And well, when you do that, you should actually get a final result of, let's see, 1 minus 1 is 0, 2 to the power of 0 is 1, 8 take away 1 is 7. So, now part B, let's see. Okay. So, use the trapezium rule with all the values of y in the complete table to find an approximate value for the integral of this. Okay, so of course we can't integrate directly, so we have to use the trapezium rule. Now the trapezium rule thankfully is very straightforward. Let's have a look. So trapezium rule is always going to be, firstly, so we just say this is approximately equal to h over 2, so now we're using trapezium rule, times the last two terms, which is 7.5 and 0. So it's always the last two terms, plus 2 times every other term in the middle, which is 7 plus 6 plus 4. That's it. And of course h represents the width, or well, the height. In this case it's the tiny little gaps between it if we divided it equally. In this case we know the gaps between every single one is 1, so h would be in this case 1. And yeah, that's it. So now all you do literally is just plug it in and see what values you get. And well, plug it in, you should get exactly, let's see, so 1 over 2 times this, you should get about 20. Oh, but that's not 20, that's a 0. 20.75. And you could say unit squared, but 20.75 is cool. Okay guys, part C. So let's have a look. So we're given a figure which shows this equation. Yep, that's clear. And if we just look at it for a second, yeah, every time they give you equation and they ask you to find the area underneath the curve, it's actually the entire area below the curve. So effectively it's every single part until it hits the x-axis. So if you want to find just this little region, we just have to realize that firstly there's a straight line here, and this one kind of looks like a right angle triangle, the white region. So if you integrate this, well, we already did, we got about 20.75 using the trapezium. All we need to do is find the area of this triangle and subtract it from this bit to get the region R. Now, how do we do it? Well, this information will just tell you what it's literally what I just told you. So we can say firstly at the point A, which is of course the furthest point, and in this case the furthest x value is clearly 4, and that gives you a y value of 0, so 0 and 4. This would mean that this corner here is going to be 4, 0, so this will be effectively 4. So we know that the width is now 4. For the height at B, this is when x is 0, meaning y is 7.5. So now the height here is 7.5. That's it. Now to find the area of a triangle, it's just base times height over 2. So you just put 4 times 7.5 over 2, and that should give you 2 times 7.5, which is 15. And then just subtract it from 20.75 and you're left with the region R. So 20.75 minus this will give us exactly 5.75.